just open it. So.
Hello, we're working with Jorg. Is that how you say it? I never asked you how you say it.
Yes, absolutely. Exactly. You can imagine me like the city of New York, like the York in New York.
Jorg. Okay. And he's going to check out our instructions for our chain development on localhost. So you're just starting this now, or have you started before? I don't remember.
We did it once briefly after installing on my computer.
So where are we exactly? Can you run the interface now, or did we get that far?
I think I can. I just haven't done it in several days. So how I run the interface? If you tell me.
Okay, you want to open an Ubuntu window?
No, it's Mac.
You're on the Mac.
Yes.
Okay, let me get that straight now. Okay, so so you want to go into your Bootstrap directory, and you want to do a /run rnode and maybe share your screen.
Just a second. Yeah, of course, I share the screen. Just a second.
Right. Yeah, I don't know how I forgot that. Yeah, you were the guinea pig for the Mac installation.
Yes, exactly. So I think I have. So it is Gov. So here I am.
And then you do the /run rnode. And if you hit the tab, it'll fill in for you. /ru tab. There's no space there. / means the current directory.
Yes.
Oh no, rnode not found. I thought we put it in the path.
I think we did.
Echo,
I don't understand.
Echo dollar capital path, and let's see what we have.
Let me just. Echo dollar
Space
path.
Oh, path is all caps. All capital letters and path. So let me move this if I can. No, I can't. Exit full screen. I don't see where.
No, I can't see it either.
I can't see where your rnode is.
It's it's the argov. So I can. So the directory path is under the under the root directory comes the I can show you. You see, under the roots directory is the argov directory, and under that is the bootstrap directory.
Right, but where's your rnode executable? That's what I don't know.
Yeah, that's a good question.
We installed it probably in your home directory. There's probably R node directory or something?
Yes, here's a directory. As you see, our node data dir is undefined.
Okay, don't worry
Don't know
about
what that
that.
means.
I
Okay.
created that when we ran it one time. Question is, where did we run it from? And how come that's not in our path? Do a cat.profile, cat space dot profile.
Tab.
Cat, C-A-T. That's the Unix
Yeah.
concatenate command.
Yeah.
Dot profile, period profile. No space, you need a space. Okay, so that is that's telling us that the R node is in users temp, which means it's probably gone. Logs R node, what? R node.bin. So the temp directory was probably deleted. I would guess.
Yes, it was in the temp directory, which gets automatically deleted. No wonder that it doesn't run.
Yeah, I don't know how we got there.
No idea. So we have to do that again.
Yeah. So do a history vertical bar.
Yes.
grep, grep space R node. Enter.
Grab or grab?
grep, grep, grep. Get regular expression.
G-R-A-E. Sorry. Of course. Yeah.
That's it. There's nothing in the history, huh? How do you like that? Okay, well, I guess we have to go back to square one, and I guess we haven't really updated the instructions much, which was the plan after you. I guess we need to add an issue to do that. So you're going to have to go to the releases directory, and we should put numbers on these things so that we know what they are. But it says install the latest R node release, like a half page down from the top.
Yes, I see it.
And we click on that releases directory, and okay, and I guess the current one is 12.1, and if we scroll down, we can see that we have a I guess we used, which one do we use? We used the R node. No. We want 12.1, not 12.0. Okay, we want the the gzip tar file, I guess.
Mhm.
So not that. Which one are you getting? Not that one.
The
Not the
tar.gz.
source. Not the source. No.
Yes, of course.
The second one there.
One.
Okay, so right click on that and copy the address.
Mhm.
Okay,
Mhm.
and now go back to your screen there, and I don't know if you can make that any larger easily.
Yes, just give me a second. I can.
Okay.
Like that?
Yeah. Okay, yeah, that helps. So now you want to do a wget space and paste in the address.
Mhm.
Enter.
Mhm. Mhm.
Okay, and now you want to do a tar space xcf xzf, I guess. Extract gzip xzf, the file, space.
XZF.
No, Z.
XZF. Mhm. Mhm.
And then rnode tab. rnode -0 tab.
Mhm.
Okay, enter.
Mhm.
Now we want to CD to rnode -tab. Enter.
Mhm.
Okay, and well, ls bin. Your rnode should be in the bin directory.
Mhm. Mhm. Yes.
Okay, and so now PWD here. PWD, print working directory. Okay, so that is where your rnode is installed.
Mhm.
So now you want to edit, you want to copy that and edit your dot profile
Mhm.
to point to the bin directory there.
Mhm.
So what editor do you use? Just, okay, see, I guess cd dot dot. And then edit dot profile. I don't know what your editor command is.
Let's see.
It's not
I
called,
usually use
not called
Atom.
Atom. Oh, Atom space dot profile.
Mhm.
Okay, and see where we have our node there. We have
Mhm.
the path.
That's
There.
the. Mhm.
Okay, so you just want to change that whole path up to
Mhm.
bin. You want to leave bin.
Yes.
And paste in there. Paste in.
So here. That should do it then.
That should do it. Okay,
Ah.
do a dot space dot profile. No space after the dot. You need a dot space dot profile. Is that a dot?
Yes.
No
Dot. I mean, the normal full stop dot.
Yeah. We just
Dot
edited that
space.
file. How could it not be there? Cat dot profile. Understand it. Cat space dot profile. It's there, all right. Type source space dot profile. See if that. No, that worked. I don't know. I guess dot doesn't work on the Mac.
Yes.
Okay, so now you can run our chain. So I guess you want to go back to your
Mhm.
bootstrap directory.
Mhm. There was just dot bootstrap.
Dot
Slash boot.
slash run Arnode
Run.
tab. Oh,
Yeah.
that's
Okay.
better.
Mhm. Mhm.
Okay. So cd dot dot and why don't you do a git pull? Just make sure you're up to date. You always do a git pull before you start
Mhm.
working. Git space pull.
Mhm. Up to date. Very good.
Okay, and now you just do a npm start, right?
Mhm. That is.
Da-da-da. Okay.
Exactly. So I need to go to the other browser because this is where MetaMask is. So here it is.
So check balance,
Mhm.
explore. Didn't,
I think I need to connect the wallet first.
oh, the MetaMask should pop up. Did you hit connect wallet again?
Here it is. Second in the way here.
Okay.
There it is. And here is the balance.
So we're all set there.
Very good.
All right. I guess now we're back to where we were before. And
Exactly.
we were, I guess we started doing the learning rholang.
Yes.
Okay, so
Learning rholang by example.
open that in a new tab. Yeah. Okay, and I guess scroll that. Scroll. I mean, look at the examples there. If you don't understand anything, we'll try it and get it to work, or see how it works.
No, I think this I understand still.
Don't worry about the storage contents. We're not going to see that anyway. But basically,
Yeah.
all the reads and writes get put into tuple space.
Mm-hmm.
And that's, and then if a read and a write match, if the pattern being read matches, then it executes the continuation
Mm-hmm.
of the read. But we didn't actually do reads yet, did we? We just did writes. Okay, so okay, and then doing two things at once. We have everything in rholang runs at the same time in parallel.
Mm-hmm.
Okay, so if we do these two things, they happen in parallel, they can come out in either order. You want to try it?
Mm-hmm. Yes, that's good.
You could put it here or anywhere, doesn't matter. Explore. Okay. Oh, what happened? It's only outputting to result in one channel.
Mm-hmm.
So on line 4, change char 1 to result.
Mm-hmm.
Now, if you do that enough times, they'll come out in different order. But right now, they're coming out
Mm-hmm.
in order every time. I don't.
Yeah. Mm-hmm. Yes, it changes order, definitely. I see that. Yes. Yeah, very good. Mm-hmm.
Okay, so when it created a new name and it wrote to that name, well, at the end of this, when this thing ends, that name went out of context. The Chan 1 name, as soon as
Mm-hmm.
the name went out of context, there's no possible way that anybody could access it.
Mm-hmm.
Okay, because the new only creates a name, and that name, is a global name. In essence, it's an unforgeable name. But unless you give it to someone, it goes away at the end of the
Mm-hmm.
procedure.
Mm-hmm.
Okay.
Just wondering, so it is global within the curly brackets here, or is it? I mean,
the unforgeable name is not.
mm-hmm.
We have a label on it, like result in Chen 1, but
Yes.
that label doesn't mean anything. It creates a new unforgeable name. Okay, that we call result or Chen 1. But the
Mhm.
unforgeable name is uh, uh, anybody who has that unforgeable name can access it. They don't
Mhm.
have to, if you send it to someone or
Mhm.
store it somewhere, okay, that's
How do I see or the name?
well, there's really not much to see. Um,
I'm thinking of how to send it to someone. I mean, so that it must be somewhere.
yeah, no, it's unforgeable. So if you just copy the bytes and send it to someone, they
Mhm.
can't use it. Okay,
Mhm.
it doesn't. There's no way. There's no way to save it offline. Okay,
Mhm.
you can create a URI for it. They have we have what's called a registry where you could register
Mhm.
the name and then use that URI to look up
Mhm.
the name. Okay, and as you'll see, we keep uh, we store the names in what we call a data locker, which is based on our deployer ID, which is derived from our public key, and,
Mhm.
and it's the deployer ID is a private name that nobody else can access except you. Okay,
Mhm.
you have to have an account. You have to you have to sign the deploy with the private key
Mhm.
in order to access the deployer ID. Nobody else can
Mhm.
do that because they don't have your private key. Right. So that's another story. Okay. I mean, we could go into go go into that uh, a little bit deeper. Um, if you uh, if you write that to your deployer, if you write that to your deployer ID, then you could read it the next time. But we didn't even get to read yet.
Mhm.
So.
Mhm. Yes.
Well, only two things you do here: send and receive. We've been through
Yeah.
send, okay, and we'll show how you can send it. Okay, so now we're doing receiving, and it uses the for structure, which is really we can say wait for
Mhm.
a message on the channel.
Mhm.
Okay, and when a message the message and the message could be a pattern. Okay, so we're really not reading. I mean, here we're really reading uh, any message.
Mhm.
Um, and I don't know. I think this is a message that matches one argument.
Mhm.
Okay, the other way we read things is with a contract, which is really
Mhm.
a persistent read. That means whenever you send order to the coffee shop name, um, we're going to execute the code
Mhm.
of the contract or what's between the curly braces there. So
Mhm.
anytime an order is sent to the coffee shop, it's going to run that code. And the first thing it's going to do is send coffee order received. And then in parallel with that, it's going to be one hot chocolate. It's going to write, oh, one hot chocolate to the coffee shop. Interesting. Okay, so that's in parallel with the contract. Okay, so if it does the read first, it'll just sit there and wait until we do the write. If we do the write first, it'll trigger when we do the read. And
so that's so
okay, so the contract is a read. Okay, and then we send to the coffee shop
so I would just to try that out, just and then tell me if I'm wrong. So if I make, let me just see, so the coffee shop variable,
the string,
like that, and I say, for example,
you're going to have to put coffee. You're going to have to make a new name, coffee shop.
yes, yeah. And result I don't need actually.
Well, if you want to get any result, you're going to need it, but
okay. But if I write it like that, I write.
We'll get the output because coffee shop is the first name you. It's the first name you introduce, and so it'll show that as in the result. So you'll.
And now.
So if you hit explore, it'll say one coffee.
And now if I basically have that, and let it run, then it receives. Or it's the same.
You have two. You have two different coffee shops here.
Yes, I see.
And you need to put a par between the first new and the second.
Like that.
Yeah. So now you can explore, right? It just says one coffee, huh? Oh, okay, because we're not getting the result anymore. The first one was coffee shop, not result. I mean, you can take off. Yeah, well, that's a different result. It's not the same result.
Yeah.
You could put the whole thing in a new with the same result, or you could take the result off.
Let's just see what happens if I have it like that. Yeah.
Okay. Well,
I feared.
You don't need that brace, but.
Oh, yeah.
What happens in one coffee? Oh, we sent that to the coffee shop. It didn't print out what we sent. Okay, so in the coffee shop contract, put order received, and then after the quote there, put plus plus, which is concatenate. Order, ORDER. Now it'll tell us. Oops,
Yeah.
what does it say? Oh, we have to put a star order because order is a name. We have to make it a process.
Star order, like that?
Yep. Okay, you might want to put a space after received, but besides that.
Yes. Yeah. Very good. Yeah, I understand. So these are the inputs in random order. Doesn't matter because it's parallel anyway, and the contract processes the order in whatever processes the message in whatever order they arrive.
Yeah, arbitrary order.
Yeah, very good. Yeah, it works, and I understand. I understand. Start understanding the logic. Yeah, very good.
All right.
Very good.
And read and write. That's the only things that our chain does. That rholang does. But there's there are some syntactic hurdles to pass. The match statement is one, and ordinarily you read something, it's gone. You send something, you receive it, it's gone. You can also peek, which lets you look at it with it, doesn't remove it. But we can go.
Yeah.
We can go on. Let's see what's next. Names and processes. Well, we already covered that a little bit. When you say new something, you're making a name. Okay. If you want the new thing to be a process, you basically have to say the name of it. So and for that you put an @ sign in front of it, which means the name of this process. Or when you use it in a process context, you put a star in front of it. Means you take the process value of this name, and you can do that back and forth. You can do an @ star, @ star, @ star. I mean, and change back and forth between the name and a process, whatever. But that was the point. The thing is that we always send processes and always receive names. And that's a very confusing part of rholang. And in fact, other implementations of rholang don't make you use the star and the @ It figures out rather than giving you an error message, it just assumes that if it's in a process context, it must be a process. If it's in a name context, it must be a name, and you get no error message. But I guess Greg, who thinks that you should be aware of the difference, which is a lot of headaches for the programmer, because it's always wrong. Always takes you 5 times to run it to get all your stars and ats properly. But what are we looking at here?
That is totally clear, and no @ yet. It's just so I guess that I get that. So
So here,
Alice gets,
Alice must
yeah.
be a name because you're sending something to it.
yes. So we send this string here, and then when Alice has that, she passes that on to Bob, which is another name, and gets that. And when Bob has it, that gets assigned to result, and by that being put out.
Right. And so we received the name message, so we have to use the star to make it
Yes.
a process. We have to send processes, receive names. And the number 2 is a process.
Mm-hmm.
This is a process.
So if I want to, at this point, if I want to do something like,
Okay.
have a result, just to show that it is here now. Let's see, does that work? No problem. Okay.
You need
so I guess I have to.
You need a par.
Yeah. So, and
So this is all in par anyway, right? So the Alice.
yes, exactly. So it's not, and that is the counterintuitive. So it's not the chain that happens, it's parallel.
Yeah. Everything happens at once. It's.
I think I have to experiment with that a bit more to fully understand it.
rholang is a concurrent language from fundamentally from its roots up. And it's a unique thing about rholang is that that it's fully concurrent. Okay, so let's just play with this a little bit. Okay, so let's make Alice a process and see what happens. So in the new there, put an @ sign in front of Alice. That means the name of the process Alice. Okay, so now if we run, we're going to get an error.
Yes.
Okay, which tells us that we got a syntax error. At 113, didn't like that. I guess it doesn't like that. I guess we can't put an @ there. Okay, so go down where it says message and put for message and make that an @ message.
Yeah.
Yeah. So now we're saying take the process, the name of the process message. Okay, now we're going to get an error on line 10 because we don't need the @ sign there. Okay, proc variable message used in a name context at 10:11. Well, if we take off the @ sign on 10, the star on 10. Okay, now we're okay. Since message is a process, not a name, because we're receiving from Alice the name. That we're saying that we want the name of the process message. So message is already a process, so we don't need a star. So I never noticed you couldn't change it in a new. Now, on 15, we have a different message. So that's still a name, not a process.
Can do that as well.
We're binding message to the to the name, and all right.
Very good. I think I understood that.
Now, okay, it's talking about public names now. Which we basically don't use public names because they're not safe. Anybody can step on them.
Yeah, okay.
All right.
Next.
That's very good. You know, I don't know if we want to. Spend much time on this. But persistent send. Okay, we don't use that either really much. That means it sends forever. Every time you read it, it sends it again, which is pretty useless.
Yeah.
Okay, this is, okay, so this is peak. And that's got the two less than signs equal. So it says, tell me when something is written to the airport info channel, I want to get that info, but I don't want to take it out of the channel. I want to leave it there. Okay, now that's going to be a problem. So here it peaks and then it reads it. So if the peak happens first,
well, yeah, I understand. Yeah. Yeah, we can try that, of course.
If the read happens first, seems like we got a race condition here. It's like it's reading the, it's never saying no wind.
Yes.
Now it's got no win. Now it's into no win, huh?
Exactly, because I changed that to the second expression here also to peak. But it stays always now on the no wind.
Hit it a couple more times.
Let's change that again as it was here. Ah, yeah, now it changed it. Okay, so that works. It seems still to be
Random.
10 exactly. It's random, but it seems to be distributed leaning towards the second.
Yeah.
But that might, of course, be artifact. Yeah, it shows up. Very good. Yeah, understood.
Okay, the way that we use that is, like when you store, when we use a channel to store a variable. We peek at it, when we want to see its value. But if we want to change the value, then we read it and write it back again with a new value. So we sort of use it as if it was a variable in the language. So what's next?
Join.
Join. This is important. You're basically waiting for two things to happen. For example, it could be a multi-sig thing. It could be waiting for me to send something and you to send something in order to do something. So the read sits there until both conditions are met, until it reads on both channels. And here we're just reading a single thing on the channel. We're not reading we're not looking for any a complicated pattern. So we say 4.
Yes.
So that means you're sending one value on that channel. Okay, so this is a button, right, where we each have to hit the launch button to launch the rocket. That's a good example. But there's many other examples. You're synchronizing. You start 10 things happening. Then when they're all done, you want to do something, right?
But now I just tried so Alice says launch, but Bob says now something different. I've changed Bob here. And if I go on explore, it still says launching rocket.
Well, what do we do with the values X and Y that we read from the channel? Nothing.
Yes.
So we don't care what you send.
Okay.
Okay.
I understand. Yes.
If you put in there, okay, if you put in there for Y, put in @ quote, take out the Y. We don't use it anyway. Okay. Put @ quote, launch quote.
Like that.
10 minutes to have them there to have this blood work done.
You want me to take them?
Yeah, works. Very good. Understood.
Okay. So that, see, now we're using a pattern. Okay. Okay. And you know,
Very good. I understand. Yeah, good.
so if you send
Mhm.
anything else, you know, it doesn't match the pattern.
Hmm.
Okay, if you put X there, it can be anything, but any one
Exactly.
thing. If you sent two things, it wouldn't match either. If you sent launch,
Mhm.
comma X or a comma
Yeah.
something else. I mean, even if you had a variable there.
Yes.
I mean, even if you didn't, if you were reading X, it still wouldn't work if you had two arguments instead of one.
Hmm. Yeah, makes sense.
So I'm going to take the dog for I'm going to be taking the dog for his shots. And I guess we've been an hour and a half.
Yes.
You know,
I
would encourage you to stumble forward.
I will. I promise you I will now. Now that I have resolved so many things and the thing is actually running again, I'm very grateful, and it's fun to try these things out, and I will make my way through, and then we discuss again, I would suggest.
Then you'll probably have lots of questions, right? So, you know,
I bet things will not work, and or I will not understand why they have certain outcomes.
right.
Yeah.
You know, and you can put questions in Discord too, right?
Yes.
And
Yeah. I'm happy to go forward with that. That's very good, and I am really grateful how nicely the tutorial is put together. That is very
Josh, you did a
straightforward.
nice job.
Yeah, very good.
All right. I guess I'll hang up now, and I will
Absolutely.
take the dog for his blood work.
Thank you so much, and very much looking forward to seeing you next Tuesday.
Yes. Well,
Have a good day.
see you then. Hopefully you'll see me then. Tuesday morning, I fly. At what time?
We can we can reschedule. Monday is also fine.
I'll let you. I'm sorry.
Monday is also fine. We can also reschedule back to Monday. There was just the one Monday that was not good. Next Monday is totally fine too. So whenever it's convenient for you.
Yeah. Did you meet Bill Kunge? I guess
Did I read? Sorry.
Did you meet Bill Kunge?
No,
Well,
I don't think so.
I may change it. I may not. Tuesday, you know, as long as I have time to get to the airport, Tuesday's fine.
Yes. Just
bye.
Give me a heads up so that I know on
Right.
Sunday, say to say. I mean, that would be all. And then either we do it Monday or Tuesday, whenever it's convenient for you.
Right.
For me, it doesn't matter. Both are fine.
Okay. Very good. Bye now.
Very good.